Alright, last couple of problems. Rhombus is how often a square? Rhombus doesn't have to be a square because it doesn't have to have right angles, but a square is a rhombus, so it's at least sometimes. Rectangle being a parallelogram has to be because the opposite sides will have to be congruent. Or sorry, well, opposite sides are congruent, yes, but also they'll have to be parallel. Trapezoid sometimes has reflection symmetry. It does when it's isosceles. That's the only time it'll have one line of symmetry then. Quadrilateral sometimes never always has diagonals that bisect each other unless it is also a parallelogram. The diagonals of a quadrilateral could bisect each other and still not be a parallelogram. So, sorry, no it can't. If they do bisect each other, it has to be a parallelogram. A quadrilateral always has diagonals that bisect each other unless it is also a parallelogram. I want to say never, because if it did have bisecting diagonals, it would have to be a parallelogram. Yeah, it'd have to at least be a parallelogram. And all that other stuff that has bisecting diagonals is still parallelogram, so that doesn't, like square and rhombus and rectangle, that's still fine. If a quadrilateral has two pairs of congruent angles, it is blank and isosceles trapezoid. Well, it could be if the angles, the pairs are like here and here and the other two, but if the pairs are like here and here and the other two, then it would be a parallelogram, and we wouldn't have that condition. So, if a parallelogram has both reflection and rotational symmetry, well, reflection, we talked about this, it has to at least be a isosceles trapezoid, or I guess a rectangle or rhombus or something. Rotational symmetry, that's where we know it has to be parallelogram, so that rules out the trapezoid situation. So we're talking about it is blank a square. Oh, it could be a rhombus, it could be a rectangle, so we have sometimes. Those things don't have to be squares, but they can be. If the diagonals of a quadrilateral are perpendicular, diagonals of a quadrilateral, then is blank either a kite or a rhombus. Well, it could at least sometimes be a kite or a rhombus. Could we get it to not even be a kite? Yeah, I think so. If you have like a diagonal and then some other random diagonal that isn't bisected or isn't really anything special to the other one, I could connect these four endpoints if those are the diagonals, and I might get just something that's really nothing. So it doesn't have to be a kite or a rhombus. According to our textbook, a parallelogram is never boo-hoo a trapezoid. Alright, because a trapezoid mandates that it can only have only one set of parallel sides. Some books say you can have two. Alright, given and our test will be in accordance with our book, of course, so don't get all upset. Alright, given the diagram, find x. Alright, so this thing, I know h is a midpoint. Why do I know that? Well, this is we have a triangle here where G is a midpoint, and this is a parallel. That ensures a parallel to this. There's a theorem that says if you have a midpoint of a triangle that's parallel, then it connects to a parallel of the another side, then it's going to cut the third side in half also. So I can be sure that 3x plus 7 and 5x minus 1 are the same. Pause for algebra time. Alright, so there's 4. And then what is GH? GH, oh, you can't see it anymore because you can't really see this anymore. GH is half of JK. And I'm serious. Because that thing, okay, that's the other part of this theorem. If you have, or the other theorem next to it, I think. If you have this thing called a mid-segment, it is parallel to and half of the other side of the triangle, so there you go. And if J is 90, okay, a lot of people are missing this. If you have J being 90, how long is it from J to H? Well, that's that situation where we have right triangle connected to, and then you connect the right angle to the midpoint of the hypotenuse. You know, all three of those are the same. You get isosceles triangles, all kinds of fun stuff starts to happen. So JH is the same as HL and HK. H is equidistant from all three corners of the triangle. And I know what these are now. If x is 4, this is 19. I can just check this while I'm at it. This is also 19. Good. So we have 19. Okay, I think that completes the review packet. There's tons of other stuff up on Blackboard in my, I think in every teacher's Blackboard. They have other documents you can use to study from. And good luck on your finals next week, and have a nice break.